I'm looking forward to talking with you today about scaling up the alternative protein supply chain, which I think is an interesting case study as a very young and emerging industry category that's really being driven by a combination of new technologies as well as the efforts of existing incumbent players. It's being driven by advances on the supply side, as well as a shifting consumer base that's looking for different things in its foods. It's a relatively young category, as I said, so there's still a lot going on. Things are changing quickly. And I think consequently, it has an awful lot to learn from other industries and other food and agriculture categories in terms of scaling up the supply chain and meeting a fast growing demand in a sustainable way. I'll be presenting for approximately 30 minutes today, and then I'll save a few minutes at the end for questions. So look forward to engaging with you all during that time. I'll start off by giving just a little bit of background about where I'm from and sort of my priors coming into this conversation. The Good Food Institute, or GFI, advances alternative proteins, and I'll define those a little bit further in a moment. We're a nonprofit think tank dedicated to creating a healthy, just, and sustainable food system. We do that by engaging with a wide variety of communities. We work with the scientific and technological communities to understand the technologies that are underpinning this industry, as well as drive them forward through a combination of advocacy, connections, and encouraging and actually funding open access research in applied and basic science in these areas. We do it through corporate engagement by working with companies throughout the entire supply chain that could be potential suppliers of equipment or services or ingredients or inputs or anything that would be involved in producing alternative proteins. And we work on the policy realm as well to make sure there's a fair and level regulatory playing field for these products, as well as encouraging global governments to invest R&D funding into, again, the basic and applied science that's driving forward this industry. And this is something that's happening on a global scale, both in the companies that we work with, as well as the Good Food Institute. We have affiliates in 6 different regions of the world and over 100 team members globally. As a nonprofit and as a think tank, we play a unique role in the ecosystem. We share the knowledge, information we have freely, whether that's consumer research, market research, technical research, policy, ideas and interventions. We really focus on the gaps that exist in the industry and finding ways to solve those, whether that's mobilizing researchers, finding an entrepreneur or a set of existing companies to fill a commercial white space, or working with, say, policymakers to apply a political intervention to address a gap or a need in the marketplace. And we take a big picture perspective. We're focused on the success of the entire industry and the success of our overall mission of a better food system, rather than just the success of a few companies. The central question that motivates us at the Good Food Institute, and I think a question that motivates many people who work in the food and agriculture space, is this one. How will we feed 10 billion people, the projected global population, by the year 2050? And how will we do so in a way that is sustainable and healthy? This isn't just an academic question. The fundamental technologies that we've been using to supply our protein up to this point have a number of enormous drawbacks, and I'm referring to the use of animals essentially as processors of plant feed crops like corn and soy into animal protein products that we know and enjoy, such as meat, egg, and dairy products. Chicken's a pretty relevant example here. It takes about 9 calories into a chicken in the form of feed crops like corn and soy to get 1 calorie out in the form of meat. That's an 11% conversion ratio. And chicken is actually relatively efficient, one of the most efficient terrestrial animals we raise. Most other forms of meat production are far less efficient. And you can see some of the numbers for beef in comparison on the lower half of the slide. This is important because when we look at any industrial process that has this low of a conversion efficiency ratio, we know that it's ripe for disruption. But there's other ways of looking at this too. Instead of just growing those crops or using that land to grow crops that can be fed directly to humans, because we're essentially bioprocessing them using chickens, we're creating almost 800% food waste before we've gotten anywhere close to further processing or the end consumer. And because we have to do that, we're using 8 times as much land, fertilizer, herbicide, pesticide, water, all of the many resource inputs, not to mention the fuel used to transport all of those things to the various places in the supply chain they need to go, which obviously combines to create an enormous resource and carbon footprint for these foods. And we can see that in data that's available from many different organizations, including our World in Data, as I'm showing here, but the food and agriculture organizations and many, many other institutions, showing there's a vast disparity because of the inherent inefficiency of animals as a bioprocessing technology. So you can see all of the foods towards the top of this list that have the highest carbon footprints tend to be animal protein foods, and the foods at the lowest end of this list with the smaller carbon footprints are the ones that tend to be plant proteins, again, where we're much closer to just harvesting crops, processing them directly into food for humans rather than putting them through a middleman, or in this case, a middle animal. This has a number of really, really important implications for how we think about building a better food system. Because of the inherent inefficiency of using animals in this way, industrialized animal agriculture is among the most significant contributors globally to some of our most pressing issues, including greenhouse gas emissions, but also land and water usage and pollution of various kinds. As a sector, industrialized animal agriculture is responsible for between 14 to 18% of global greenhouse gas emissions. That's more than any other economic sectors, including things like transportation. So all planes, all trains, all cars, et cetera, still aren't as big of a contributor to greenhouse gas emissions as the industrialized animal ag ecosystem. The land usage implications, as I've alluded to, are pretty enormous as well. We use about 75% of global agricultural land to raise crops for animals or to raise animals on that land, and yet that only provides about 1/3 of our protein supply globally. Think of it a different way. We get about 2/3 of our global protein supply from less than 25% or 1/4 of our agricultural land, just by, again, growing those crops and feeding them directly to humans. There's also a number of other important health and safety implications, including because of the fact that we're using industrialized animal systems, we have to keep those animals in close confinement. That creates a lot of disease. It creates a lot of sort of dirty conditions that give rise to the need for administering things like antibiotics prophylactically. And so we use way more antibiotics in our in animal agriculture system than we do in our human health systems, which contributes to the rise of things like antibiotic resistance, which is something that not a lot of consumers necessarily know about, but something that really should send a tingle of fear down anybody in the supply chain. It's a really horrifying thing to think about, antibiotics losing their efficacy. So we know there's a lot of challenges and problems with the way that we currently produce protein. But part of the problem too is that for a lot of consumers, this is invisible, and we love all of the products we get from animal agriculture. Meat, egg, and dairy products are deeply embedded in our traditions, our cultures, our cuisines. They're delicious, they're really, really affordable, and they're incredibly widely available globally speaking. And we don't think that at the end of the day, asking consumers to give them up is a really good idea. Rather, what we pursue at the Good Food Institute and what many of the companies in this industry sector are pursuing is a way to create these exact same products, creating meat, egg, and dairy products more sustainably by using alternative technologies such as plant-based protein, cultivation, or fermentation. And instead of asking consumers to make a sacrifice by giving up foods that they love, just ask them to have something that's made using these technologies instead, and by providing them products that are just as delicious, just as affordable, and just as widely available and accessible is what we're replacing. So the three main technologies that we focus on at the Good Food Institute are plant-based proteins, fermentation-derived proteins, and cultivated, and I'll look at each of these in turn. Plant-based is probably the one you're most familiar with. A lot of companies such as Beyond Meat or Impossible Foods have gotten a lot of attention and press for making very realistic meat analogs, for example, from plant proteins. And it's essentially just using crops that are processed for their protein, and then that protein is further processed into a product that is delivering a sensory experience that's similar or equivalent to an animal meat, egg, or dairy product. Fermentation refers to the use of microorganisms, either as a processing aid or as a way to create whole cell biomass, such as the case of like using fungi or algae as inputs for these products, or even using bacterial or yeast microorganisms to essentially hack them as little micro factories that can synthesize high value added proteins through precision fermentation or recombinant production. So this is also an area we see as being a key part of both producing ingredients as well as key inputs, protein inputs and biomass for this sector. And then cultivated meat, which is using animal mammalian cell culture technology to take cells from animals, take tissue cells, muscle, blood, fat cells, and culturing them or cultivating them in bioreactors to literally grow meat directly from cells and bypassing the animal, and in the process, unlocking a lot of additional efficiencies. Instead of growing a whole animal and not eating most of it, and that animal has to live its life and walking around, we can just grow the parts that we really want, which at the end of the day ends up being certain types and cuts of meat. So why are we talking about this? Why is this suddenly everywhere, getting a lot of attention and focus from consumers? Well, it lies in the intersection of two major shifts, we think. One is on the supply side. Manufacturers have started to make products that actually taste good and are actually priced in a way that makes them affordable to mainstream consumers, and making these products much more widely available in the restaurants and grocery stores that consumers are used to shopping at. And on the demand side, consumers are changing their tastes as well. A large majority of people are interested in reducing their animal protein consumption and increasing their plant protein consumption. And we see that reflected in stats like this, which we can source from a wide variety of places, and it really bears out globally that generally speaking, most people tend to fall into an omnivore category where they're consuming both animal and plant protein products. But there's a large segment of the population, usually between 20 to 40%, depending on which country we're looking at, who are flexitarians, who are, again, are actively seeking out ways to increase their plant protein consumption and reduce their consumption of animal proteins. There's a much, much smaller slice of the population that's vegan or vegetarian, where they're abstaining from certain types of animal proteins completely. Previous generations of plant-based and alternative protein products really did focus on that niche audience, but the latest generation of plant-based and other alternative protein products is focused on flexitarians and omnivores, and so it's representing a much larger business opportunity and gaining a lot more traction in the marketplace. A lot of what consumers say matters when you ask them on surveys. Why are you trying to eat more plant proteins, or why are you trying to eat less animal proteins? They'll say things like health, or they'll mention things like sustainability. And those are important drivers. And there's certainly some element of the consumer base that is truly strongly motivated by that. And it is an important aspirational driver of behavior. But at the end of the day, what we've seen from market research, from actual sales results, and from consumer research studies that we've conducted, and what I think really holds pretty true with all of our, just sort of anecdotal evidence of our own behavior, is that what really motivates long-term loyalty to particular foods are more these things. They're widely available. It's something we can obtain at the restaurants we enjoy going to and the grocery stores that we're used to purchasing from. They're affordable. It's something at a price point that we can integrate into our daily, our weekly consumption patterns without noticeably affecting our wallets or really swelling our food budget. And they're delicious, of course. Taste is king. If you don't like the taste of a food, odds are pretty good that unless you have a doctor's order, you're not going to keep eating it, or it's something that you're being forced to in some other way. So at the Good Food Institute and with many of the companies that are working in this space, these are the product attributes that we emphasize. And it's not rocket science. It's something the food industry has known for a long time. But these are also attributes where previously generations of plant-based and alternative protein foods have really fallen short, particularly not tasting very well, not being affordably priced, and not being widely available. We think that over time, we're still very much in early days, but over time we expect that plant-based meat products and other alternative proteins can diffuse throughout the entire innovation curve here and reach almost all mainstream consumers. And part of the reason we feel strongly about this is that we've already seen it happen, at least in the United States and several other global regions, with the rise of plant-based milks like soy milk or almond milk. About 20 years ago, those were just almost non-existent categories. They existed in little cardboard bricks that you'd find in the center of the store as shelf-stable or ambient temperatures. But a few decades ago, once marketing shifted a little bit, once those plant-based milks were moved into the dairy case, the refrigerated dairy case alongside animal dairy products, and once they were put in more attractive, appealing cartons, such as gable top cartons, sales really started to explode. And it started with soy milk, it's really moved into almond milk. And now we've just seen a real proliferation of different types of milk, including things like oat milk, taking over and growing extraordinarily rapidly. And for being almost nothing, that category has risen to become about 13% of US fluid milk sales in US retail stores, so within grocery. Fairly impressive growth and very, very high household penetration numbers. What we've seen from that is that the vast majority of people buying plant-based milk are also buying animal-based milk as well. They're using it. Maybe they have a preference for one or the other, depending on the day, depending on the occasion, or maybe it's for different members of their household. But what we're seeing is that this revolution is being driven by omnivores, not people who are just giving up milk or other types of animal proteins entirely. And we think that because of that, things like plant-based meat or plant-based eggs absolutely have a pathway to achieving a very high market share penetration and can do so fairly quickly, even though they're a little bit smaller today. Plant-based meat, for example, is about a 1% market share in US retail or grocery sales. Sales results and consumer research aren't the only reasons we're optimistic about the future of this category. We're seeing a lot of the conventional protein players who are already in these markets starting to invest in or launch product lines in these categories because they see it as a way to participate in their own disruption or find ways to not be disrupted by this new category. These are the 6 largest meat companies active in the United States. And what you can see from this list is that all of them have launched some form of plant-based or alternative protein product that they are manufacturing. And a few of them, and many, many others outside of this list, have invested in plant-based or alternative protein startups as a way of keeping their fingers on the pulse of innovation that's happening in this space. One of our favorite quotes is from Tyson CEO Noel White, or former Tyson CEO, I should say, who expects Tyson to be a market leader in alternative protein and could someday be $1 billion business for our company. I think a lot of these companies really see themselves as first and foremost protein companies and recognize that if consumers don't really care or want that protein to come from different sources besides animals, that they're in the business of supplying meat or eggs or dairy, and it's important for them to meet consumers where they're at. There's a lot of potential operational and manufacturing advantages to working with alternative proteins. I'll just go through a few of them quickly. A lot of this also, I should note as well, are things that have yet to be developed. So they show potential or promise in these areas, but a lot of these advantages have yet to be realized. One of the things that we think is really most cogent here is that we are doing fundamentally assembly in this manufacturing environment, or it's additive manufacturing. It's not disassembly. When you're slaughtering animals and processing them, you're fundamentally just sort of disassembling animal bodies into the ways in which you need them to be. This allows us to design and build or construct food products from the ground up with a lot of customizability and control over what happens. Some of those are fun implications, like the ability to create branded products in a much more controlled way. Maybe we're able to create custom types of species or custom blends or new types of flavors or meats that really haven't existed or represent hybrids of existing things that consumers are familiar with. It's certainly the case that maybe the species we eat are truly the tastiest out there, but it's likely that we are eating them because they happen to be easy to domesticate several thousand years ago. And so if we were able to explore a little bit further, we could probably determine and find new types of meat that are even more exciting to the human palate. It also gives us the ability, because we have end-to-end process control, to modulate nutrition. There's a lower prevalence of bacterial or fecal contamination because we don't go through a slaughterhouse process in producing plant-based and alternative proteins. We have a lot more control over the vitamins, the macro and micronutrient profiles, even the types of fats, and not just the amount of fat, but the types of fat that are used. Maybe we swap in a heart-healthy fat in our bacon instead of using a high amount of saturated fat. The improved shelf life comes from the fact that there's just a lower amount of bacterial contamination that's going on in the production process. And we're also able to make this almost anywhere. So the idea of producing fresh seafood, for example, say in the middle of Nebraska or Kansas, isn't all that, it's very easy to do in theory. It also enables us to produce just the highest value meat cuts. So currently in animal protein world, there's a carcass balancing problem, right? Where we grow this whole animal and the animal moves around and we're growing a lot of parts of the animal that are super low value or have no value at all. So things like bones or a lot of the organs, and potentially certain types of skin or just other byproducts that really we have no use for. Even on the meat side, we end up with lower value cuts of meat or lower value types of meat, as well as higher value cuts. Well, with these processes we're talking about, plant-based and alternative proteins, we can just focus on the highest value cuts, the most valuable pieces of the animal, the types of meat that people have in most demand. And so eventually, if those types of products end up being just as easy to produce and just as widely available and cheap as producing maybe lower value things like some of the ground type products, that forebodes, we think, a real shift in consumption patterns, because you can just truly have the highest quality products or the highest, most desirable product anytime you want. And there's also a lot of advantages in terms of being easier and faster to produce. There's much shorter feedback loops and volatility in terms of supply. We've seen this happen before. We've seen animals as a technology be superseded. It's happened in transportation, in fuel and energy, and even in things like food storage and tradable wealth. We used to rely on horses and pack animals. Now we have cars, trains, planes, automobiles, etc. We used to rely on whales for lamp oil. We used to rely on draft animals to pull plows. Now we have electricity and tractors. We've relied on animals for a lot of things, and they've been disrupted by other forms of technology. And so we see this exact same thing happening right now in the food and the materials system, and probably in other areas of human efforts as well. We've already started to see this happen in the sense that plant-based 2.0 is really reframing how we think about meat, egg, and dairy products. We've already abstracted meat away from the animal. And a lot of that has been happening for decades, if not hundreds of years, because we've had advancements in supply chain technologies, like the advent of cold shipping, which enabled for centralized and industrialized processes of slaughter. We've also shifted in how consumers think about meat or the idea of egg or dairy products, from primarily being about this is a hunk of tissue to being something that is a particular function, it anchors my plate, or a particular type of experience. It's a certain type of flavor or a certain grouping of flavor and texture that I've come to expect. And we really view that the next evolution or the next stage of this evolution is integrating plant proteins and other alternative forms of proteins. We're not the only ones who think so. This is a summary of different projections from market research groups and folks who focus on predicting the future of these markets. Obviously, there's a lot of variance, but overall, there's a lot of optimism that this is something that can capture a very significant market share, both in the United States and globally over the next few decades. And I want to talk a few minutes just about where we see the supply chain going and where I think we need the most help as an industry category. First, at a high level, a lot of the value chain for producing things like plant-based meat is really similar to existing supply chains for producing animal meat, with a few things towards the beginning, of course, being significantly different. For one thing, we're focused a lot more on optimizing the crops and raw materials that go into these products. They're obviously quite different from what goes into the animal protein system. And then the manufacturing process itself and production method for adding texture and structure is often quite different. But as we move into some of the downstream processing, a lot of the packaging, a lot of the things like individual quick freezing, marinating, coating, a lot of the technologies are analogous to what's already used and can be repurposed fairly easily. And really, the closer we get to the consumer, the more similarity or resemblance this value chain bears to the existing conventional one. That said, there's an awful lot of opportunity, we think, for technological and scale improvements across the entire value chain, from breeding better crops to finding better ways of processing those raw materials, the harvested crops, into the ingredients such as protein isolates and concentrates that are used to create these products, finding better ways to formulate them so that they are more delicious, so we can improve texture and fat challenges, as well as lower prices, and find better ways to manufacture them. One of the things that I think is most important to highlight is that a lot of the most advanced plant-based meat analogs currently rely on high moisture extrusion as the primary way of obtaining texture and structure. And while that's really useful because we can repurpose a lot of this equipment, it's also an area that needs a lot more study. We need a lot more capacity in this area. We need higher throughput systems. And we're really interested in both better forms of extrusion as well as alternatives to extrusion that can provide texture and structure to plant-based proteins and align those sort of globular plant proteins into more fibrous, aligned muscle tissue-like structures. We also have a massive scale problem where a lot of the demand is outstripping supply. And so we have a massive shortage of both contract manufacturers as well as self-operated manufacturing capacity. And there's a massive amount of need. We're doing a lot of analysis right now to try to understand, both on the end product manufacturing side as well as some of the upstream ingredient and raw material processing side, what capacity is needed. And there's an awful lot where we're going to need the ability to work to repurpose existing facilities as well as do greenfield development of new facilities. So this is an area, I think, where there's a lot of growth and need for investment coming up in terms of expanding these capacities and also finding ways to repurpose stranded or underutilized assets that are available and can be repurposed from other industries, as well as finding the investment dollars to make it happen. On the fermentation side, fermentation is essentially just using feedstocks, of allowing microorganisms to feed on those. And in that way, we're either processing crops into something that's more functional. We're using those microorganisms themselves as a source of biomass. Great example would be something like mushrooms, fungi, algae, that type of thing. Or we're synthesizing proteins from these different microorganisms and then recovering that and purifying it into a final product. And there's an enormous amount of optimization research that's needed across each of these spaces. There's also sort of similar infrastructure and investment priorities in the supply chain side. So finding ways to increase production capacity and then the upstream processing capacity, as well as downstream processing capacity. Things like drying and downstream purification and recovery are areas that are energy intensive, often expensive, often difficult types of expertise for a lot of the startups and companies in this space to do. And we also really need capacity at various scales. This one applies as well on the plant-based side, but it's a need that's even more pressing in fermentation, having access to pilot level facilities and demo level facilities so that we can scale up these technology packages to make sure they work at various scales, and in that way start to obtain the sort of de-risking information we need to operate and get investments in plants that can run at full commercial manufacturing levels. And one of the ways, and of course, in which we hope to do that, it's alluded to before, is retrofitting existing facilities. Cultivated meat is something that's not quite on the market yet, so it's a little bit more something that's pre-commercialization, but a lot of startups and a lot of companies are working towards it. We essentially take a cell sample from an animal. We allow those cells to proliferate inside of a bioreactor, which is essentially just like the big giant steel tanks that you would see at a brewery, a little bit more advanced. And we're feeding it through via a nutrient media, cell culture media, all the nutrients it needs, those cells need to survive and grow, providing a scaffolding that allows for structurization and creating a 3D structure for those cells to grow, and then harvesting the resulting product. Currently, this is being done at probably pilot to demo scales by a handful of companies, and we fully expect down the road, as with other types of the rest of the supply chain, that we're going to need access to additional infrastructure capacity at various scales. And in particular, this sector is very much in need of partnerships from folks who have access to knowledge about cell culture media, about operating bioreactors at scale, and finding partners who can help in an investment sense with the long-term proving and de-risking of this technology. We also, as an industry, really need to focus on finding ways to utilize all of the different fractions or side streams or co-products of the various crops or biomass inputs that go into these products. So finding ways to utilize the starch fraction, the fiber fraction of all crops, as we've generally found uses for the oil, and certainly as a plant-based industry has an enormous demand for a lot of the proteins, particularly the high molecular weight proteins. But finding uses for those other side streams is important, both from a profitability standpoint, of course, as well as from a sustainability standpoint. There's an enormous amount of opportunity, we think, in shifting the types of investments that come into this category, moving from just a venture capital model that's primarily equity-based to moving to more debt-backed financing, as well as finding just different types of investors who are interested in infrastructure as an opportunity and view alternative proteins as enough of a growth market to be willing to invest in the facilities that we need to build out in order to help the supply chain keep up with fast-growing demand. We think this is low-hanging fruit because to date, there's been a relatively small amount of R&D invested in this space, about 1 billion total combined R&D to date. This chart is comparing that to the global R&D investment in renewable energy in just 1 year, 2011, which is almost $250 billion. So we're looking at a lot of low-hanging fruit here. If we can just invest even a small percentage of what's already going into renewable energy into this sector, there's a lot more to explore. And while we've certainly seen a lot of growth in venture capital investments, and that's a positive signal for the future of this category, there's still a lot more need, particularly as I alluded to on the growth capital side and scaling the infrastructure requirements. At the end of the day, though, as I alluded to, this is a very young category, and as it grows, we really expect that the products will continue to improve as we're able to disseminate new technologies, new knowledge from research, and find ways to improve the supply chain, including by getting more suppliers involved and finding ways to increase the infrastructure investments in order to invest in expanding processing and product manufacturing capacity. We are doing a lot of work in these areas. There are a lot of other groups operating. I would just highlight a few areas where I think that we're interested in looking at case studies and best practices from other industries or other sectors who have examples of how to rapidly and sustainably scale various types of supply chains and the manufacturing infrastructure required. There's a lot of different types of analyses that we're hoping to do and looking to do, and would love to hear from others who've gone through this or have great examples of how to do this. In particular, finding ways to use existing assets, existing facilities that we can repurpose, and also finding ways to rapidly scale, de-risk, and commercialize research and development that's happening. We get a lot of the same questions over and over again, and as I was looking through these questions, what really came to mind for me was that this is the type of questions we see asked in a lot of industries. We have listed out on our website, which hopefully will be available in the slides, with the slides afterwards, but it's just gfi.org, some of the most pressing challenges we're aware of at each stage of the value chain, and we have a corresponding database of solutions. that addresses research opportunities, commercial opportunities, as well as ecosystem or like policy level interventions in the supply chain. And I'm just going to skip ahead through a few slides here to conclude and jump into the Q&A. If we back up and really take a long view, chicken has been the protein growth story of the past 50 years. It's grown from being a relatively small share of the market to a massive share of the market, both globally and in the US. But we think we're on the cusp here of another major revolution. Plant-based has been sort of number 5, the 5th largest center of plate protein. But we expect that within the next couple of years, plant-based meats and plant-based proteins will surpass fish and seafood to become the 4th meat. All it would take is the average American, at least in the US, eating about 2 3-ounce servings per week of plant-based protein for it to replace seafood and fish as the 4th most popular center of protein category in the US. So we think this is very close to the tipping point of being just as mainstream as seafood and fish consumption somewhere like the US. I'll close by just noting that we have a variety of business resources, including market and consumer research reports available on our website, gfi.org. We also have a number of technical resources if you're interested in understanding some of the science and technologies that are driving forward this category. And I'll close there. There's our website. And it looks like we just have a few minutes left, hopefully with some questions.